Okay, so we are going to go into, Julie, can you put that down? Find all of the zeros. Okay. So this one, it just takes a little while, but it's not that bad. The first thing you need to know, I'm actually just going to paste this over here because it'll help guide me too. Okay, these are just the basics that you need to know. It's back over front, then drop down, and then factor. We'll get to it little by little. First things first is going to be back over front. Well, first of all, is it in order? Yes, it is. We have, yeah, it's all in order. It's from highest to lowest degree. Okay, the back would represent this, and the front is this. And basically, it's the first coefficient. It's the first, I mean, in this case, it'd be the leading coefficient, but in this case, it's just, but I'm referring to just the number in front of the first term. So, make this a little smaller. This is 1, and over here we have 20. So basically, what you have to do when you're finding all of the zeros, you have to list all of the factors of this number and all of the factors of this number. And it's basically this number, all of the factors of this number over all of the factors of this one. And we're going to do it right now. So it's negative 20. Actually, let me check one thing really quick. I don't know if the negative part of it is important. No, it's not going to be the negative part. Okay. So it's not going to necessarily be negative 20, but 20 in general. So we're just going to work on that 20. Okay, so 20, what are the factors of 20? Positive or negative 1, positive or negative 2, positive or negative 4, positive or negative 5, positive or negative not 6, not 7, not 8, 10, positive or negative 20. Yep, I'm pretty sure that's all of them. And it's positive or negative again because a negative times a negative is a positive, okay? So all of those are the possible factors for 20. And over here, we have just 1. So it's positive or negative 1 because they're the only factors. If this one over here, if the number that was right there, let's just say was a 6, for example, then you would have to do positive or negative 1, positive or negative 2, positive or negative 3, positive or negative 6, okay? But in this case, because it's just positive, it's just 1, you're going to just have that 1. I'm going to show you a really quick example right now, just sideline. It's not related to this problem, but it's related to find all of the zeros. Let's just say you were to get, okay, let's just say it was written x third. Well, let's do 4x third plus x squared plus x plus 2, okay? We have to get the back and we have to get the front. So for the back, we have positive or negative 1 and positive or negative 2, okay? And for the the front, we have positive or negative 1, positive or negative 2, positive or negative 4, okay? When you're doing this, you have to keep in mind, because in this case, we have more down here. You're going to have fractions, and that's going to be because of this. You're going to have a 1 divided by 1 is a 1, so you have a positive or negative 1. Hold up, let me make this smaller. There you go. These, because now you're dividing, because now there's more to divide by. The reason why we don't really worry in this one is because it has a 1, so anything divided by 1 is just this. So these are your possible zeros. But in this case, these aren't your possible zeros. You're going to have more. You're going to have some fractions because everything is being divided. So 1 divided by 1 is 1, so we have positive or negative 1. 1 divided by 2 is 1/2, so positive negative 1/2. 1 divided by 4 is positive or negative 1/4. Then we have 2 divided by 1, we have positive or negative 2. Sorry, I'm going to start doing them down here. Or no, I can keep going, sorry. 2 divided by 1 is positive or negative 2. 2 divided by 2, we have 1, which is already there, so we don't have to put it twice. And 2 divided by 4 is 1/2, because when it's simplified, it's 2 over 4, which is equal to 1/2, so we don't have to put it again. Okay? But then these would be your possible zeros, okay? That's just in case you have more on the bottom that are going to be divided, because unless the number at the bottom is 1, because if the number at the bottom is 1, then all of these in the numerator are your possible zeros. But if it's anything other than 1, you have to divide them. and put them in little by little, same way as I just did this. I would go look back at this, or I would go look at more math lab like practice, but that's basically what you're going to do, okay? So back over here. So in this case, these are our possible zeros. So now we have to find out what the real zeros are. And I don't know why this is a thing, not gonna lie. I have no idea what's the point of having to try to find the possible zeros, but it's going to ask you. You're going to have a question, at least one on the test. It's going to be like, find all the possible zeros and then keep going. So what we're going to do is we have to solve and try to find the real zeros. And what are we going to do? We're going to use all of these numbers, and we're basically going to test until proven true. Okay? I should make that a thing. Test until proven true. Test until proven true. Okay? So you're going to start with, let's just do -1. And we're going to do synthetic division, okay? So what do we have? We have a +1, we have an 8, we have an 11, and we have a -20. So we put that 1, we put that 8, we put that 11, and we put that, oh, that's a -20. Whoops. We put that -20, okay? So we bring it down over here. Oops. We drop the normal 1, the first one. 1 times -1 is -1. We have 7. 7 times -1 is -7. That's 4. 4 times -1 is -4. We have -24. Again, you always subtract from here. Oh, wait, actually, we don't have to do that because we're not writing it out again. In this case, when you're solving a test until proven true, like that it's actually a 0, the only way that it's proven true is if the remainder is a 0. This needs to equal 0. Obviously, this doesn't equal 0, so this is false. Okay, so this doesn't work. -1 is not one of the zeros, okay? So we're going to keep going until this equals 0 over here. So now we're going to go, let's just make this smaller so it gets out of our way because it's wrong. So why are we going to waste space on wrong things? So then we have let's do 1. Let's start small as you can, and then keep going up. So we have 1, 8, 11, -20. So we have 1. 1 times 1 is 1. That's 9. 9 times 1 is 9. That's going to be 20. 20 times 1 is 20. And what do we have here? -20 plus 20, -20 plus 20 or 20 minus 20, whatever, is 0. So this, because it has a remainder of 0, it is true. Okay? So that means we don't have to keep looking. We don't have to be testing because we've tested till proven true. So we have true. Okay? So now what are we going to do? Remember not this one, when we talked about how over here it's always going to be backwards, how it's going to be the -1 because it's set equal to 0. In all reality, this 0 has been set equal to 0. So if it were to ask you to write it out again, like expanded, this would be x minus 1, because when x minus 1 is set equal to 0, x is equal to 1, which is the 0 over here. Okay? But I don't know if it's going to ask you to write it out. I just know that in my examples in the past, I had it written out like this, and then I'm going to continue like how we actually keep solving the problem. I don't know if this is necessarily necessary, but it's good to know. It's good to understand. So now we're going to rewrite it. And that now, because it was proven true, hello? What's this? Okay, there we go. Because it was proven true, now we're actually going to do that -1, -1, where we take it away and we rewrite it. So now we have, this is our main one. 1 is just always going to be, there's going to be an x because there's the imaginary 1 in front. X, we had 3, so now we're going to have a 2 plus 9x plus 20. Okay? And now what are we going to do? Now we're going to do this. We're going to have to factor this further because you can't just leave it there. You can't say that this is your 0 because that's not one of your zeros. You're going to factor. So again, this is the way I do it. I could always just ask you which two numbers when multiplied together equal 20, but when added together they equal 9. I could ask you that. Wait up. Hello? Oh, no. This isn't good. I'm pretty sure this is going to need quadratic formula. Yeah, this is probably going to need quadratic formula. That's not going to be pretty. Well, we're going to try it. We're going to try it unless I did something wrong, but negative b plus or minus square root of b squared minus 4ac over 2a. Okay. Let's really pray that this actually works out and I didn't make a mistake. So negative b. So this is your a. This is, wait up, 2a. So this is your a term. This is your b term. This is your c term. Okay. So we have negative b. So negative 9 plus or minus square root of 9 to the power of 2, which is 81, minus 4 times a, which is 1, times c. I'm just not going to put the 1 in because 1 times anything is that number. And then c is 20. So negative 4 times 20 is negative 80. We have 81 minus 80. Okay, wait up, 2a. Negative 9 plus or minus. That means that this is going to be square root of 1, which is equal to 1. Equal to 1. And then we have this 2a I never actually did. 2 times 1 is 2. Okay. So now we have negative 9 plus or minus 1 over 2. Okay, so negative 9 plus 1 is, if it was negative 9 plus 1 over 2, we have negative 8 over 2, which is equal to negative 4. And if we have negative 9 minus 1, we have negative 10 over 2, which is equal to negative 5. Okay, both of those matter because it's plus or minus. So that means your possible zeros are going to be negative 4 and negative 5, and this 1. So if I were to ask you what your zeros are, you have, I think it's in solution set, 1, negative 4, negative 5. Now let me double check that right now. Let me actually put that in some kind of calculator to make sure I didn't mess up anywhere. You know what the calculator is going to be? The calculator is going to be here. Let's figure it out just to make sure. I really don't want to give any false information. So, yep, we were right. Okay, so if you look at this if you ever look at this and, or not that, but this part over here, and you realize you can't just be like, when you add them together, they equal 9. When you multiply them, they equal 20, and nothing's working, you're going to have to do this. So have that memorized in the back of your head, always and forever. I think that's why I chose this question yesterday or the day before, because I probably knew already that it was going to be a difficult one, and that was what made it difficult. So that's that question.